Hello and welcome to this fourth video that contains an example of first-order decay problems. In this one, we're going to estimate the time for a quantity to decrease by a certain percentage. Here's the question. Forced vital capacity, the amount of air you can exhale with force in 1 second, decreases by about 1.5% per year after the age of 25. At what age will FVC have decreased by 30%? Alright, as with the other examples, we would begin by writing down our first order decay equation. CT equals C naught e to the negative KT. Well, here we're not talking about a concentration, right? We're talking about this FVC, so let's just replace C with FVC, so FVC at some time t is equal to the starting FVC multiplied by e to the negative KT. So we want to know at what age will FVC have decreased by 30%. Well, when FVC is 30% lower than it is at age 25, it will be 70% of the starting FVC concentration, right? So we know that's a ratio, so let's just put that ratio over on the left-hand side. FVCT over FVC naught is going to be equal to e to the negative KT. We're interested in time, right? So let's solve this for time. So that means we need to take the natural log of FVCT over FVC naught. That will be equal to the negative KT, and then T will be equal to the natural log of the ratio of the two FVCs over negative K. Right, so do we have all of that? FVC at time T over FVC naught, well that's going to be, that ratio is going to be 0.7 because we want to know when FVC has gone down by 30%. So this term will be the natural log of 0.7, and then K, that's going to be, that's our decay rate, that's 1.5% per year, so that's 0.015. So let's plug in those values. T for a 30% decrease, it's going to be equal to the natural log of 0.7 over negative 0.015 per year. So if we do that, we get negative 0.357 for the natural log of 0.7 over negative 0.015 per year, and the time therefore to decrease by 30% is 24 years. But the question was, at what age will FVC have decreased by 30%? Well, that age will then be 49 years.